It's the orientation of the rectangle and whether or not you can do something with that information. Because if you have a rectangle and it's oriented horizontally, for example, but the algebra doesn't work out, then you say, well, okay, I need a vertically oriented rectangle. What method will allow me to use that concept? All right. So hard to see, but this is the y-axis over here, and that's what we're spinning around. And the shaded region, obviously, is what we're spinning. So let me zoom. So a lot of this information is extraneous. It says bounded by all this stuff, but then it actually bounds it for you. So really, we just need to know what the functions are called and where it's being spun. Okay. So I have y equals 1 over x. I'm going to hold on to that thought. I want to revolve around the y-axis. And this actually strikes me as more of a disk method type of concept, where it's like, well, the bounded region, well, it really could be, if we shift the function, we could bound that with the axis and get it all done in one shot. But and it's even easier if we're spinning it around the x-axis. But in this case, we want to learn about the cylindrical shell method, so that's how we're going to do it. And besides, it's a little easier anyway. So I need a rectangle that is parallel to the axis of revolution. So drawing your rectangle initially is going to answer the question of d what? dx or dy? In this case, dx, because the thickness is along the x-axis. All right? If I want to use the cylindrical shell method, I need really 3 pieces of information, one of which I already have, the d. I need the p and the h. The p is the distance to the axis. I wrote this on a previous page, but it doesn't hurt to have it a second time. The axis of revolution. And h is the height of the rectangle. So, p would be this distance. The distance from the y-axis to any point in space is always known as x. So p is equal to x. The height of the rectangle would be right here. The distance from the x-axis at any point in space is known as y. So the height of the rectangle is equal to y, but it's specifically the y that falls along the curve, which is defined as y equals 1 over x. My thickness is in terms of x, so that's telling me that both of these functions should be defined in terms of x also. All right, so if I left, for example, the height of the rectangle as y, that would be a problem because that's not correct. Right, based on what we see right here, which comes from that. Right, so knowing how to draw your rectangle is incredibly important. So 2 pi, most common error for any student on this topic, on any time I've ever given a test, has been just forgetting the 2 pi. It's 2 pi times the integral of PhD. So, and the integral starts and stops where the bounded area starts and stops. So going from 1 to 4, the p, which is x, the h, which is 1 over x, dx. So, and you know, we won't do it the other way, but let me just talk to you about it, just to give you a sense. In order to do this the other way, what you would have to do is find, using the washer method, what this would be if you were to spin it around the y-axis. So you'd have an arbitrary rectangle going from 1 to whatever this is, 1/4, 1 to 1/4, one rectangle spinning around for that, and then one going from 1/4 to 1 the rest of the way. So the whole shebang down, and then you'd have to subtract off the cylinder that would be created by spinning the interval of 0 to 1 around the axis, because there's going to be a hole in the middle of this thing. All right, so a lot of integrals, and you know, I can't promise that they'd be easy to work with. This one Well, it is easy to work with. I mean, this one is even worth doing by hand, because the antiderivative of 1 is x on the interval of 1 to 4. I mean, you could do it using the shortcut, which is multiply your constant by the difference between the bounds, but I'm assuming you didn't want to do that, right? So you get 3 anyway, either way. So we're looking at 6 pi.
I don't know if I'm just forgetting, but that notation, does that mean the antiderivative, extra derivative over that interval? Or?
Yes. All right. So then the next one, still the same idea. We're spinning, we know where we're spinning it. It's just a question of what the best technique is. In this case, it's saying use cylindrical shell method, even if indirectly, because it's saying explain why it's necessary to use the shell method in this problem. Well, then that means it's necessary to use the shell method in this problem. No other method's going to work, right? So we have our curve here, which is pretty hefty, x cubed plus x plus 1. Alright, so I want a rectangle that is parallel to the axis of revolution, which means its thickness is a horizontal thickness. In coming up with the solution using cylindrical shells, you'll see why it was necessary to do cylindrical shells. All right, so I need the p value, the p function, the h function, and I have dx. So we're living in the realm of x. Fortunately, that means that I'm starting, well, it's 0 here, even though it doesn't say it. I'll take that as a typo. Going from the x value of 0 to 1. So I could start writing my stuff here, 2 pi on the interval of 0 to 1, some p expression, some h expression, dx. So I need p and I need h. P is the distance from the rectangle, center of the rectangle, to the axis of revolution. So this would be my p over here. But I got to figure out what that would actually be, because I know that this distance here, let me just do it actually a little bit up here. This distance would be equal to some value x. Any movement from the y-axis to a point in space horizontally is going to be an x movement, right? But I need everything else, since we know that the whole distance, so from let me do it up top actually. So from here to the axis, that's a total of 2 units. So if I take the 2 and subtract from it the part I don't want, I would get p is equal to 2 minus x. That's the distance from the center of the rectangle to the axis of revolution. All right, so 2 minus x. So I can pop that in. All right, the other part is the height of the arbitrary rectangle, which usually comes from the function itself, the curve that's bounding the region. So I have the distance from the x-axis to any point in space, which is y. But I have a chunk of space that I don't want. I don't want any of this. That's constant, though. That's constant at 1. So it's y minus 1. Now they tell us, and this is the key to understanding why we're using this technique to begin with. They tell us that y is equal to x cubed plus x plus 1, and then we have a minus 1 built in there. So it becomes our h, x cubed plus x. All right. So it's necessary to do it this way, because disc and washer would require a horizontal rectangle. That horizontal rectangle, instead of having a dx, would have a dy. We would need to solve y equals x cubed plus x plus 1 for x. All right, we would have to do that. Okay, so let me go to 200%. Necessary to do it this way because the disc and washer method would require a horizontally oriented rectangle, so dy, so dx. So we would need to solve that cubic equation for x in terms of y. Not easily done, if doable at all. All right. My sense is, I've never even tried because of what my senses are telling me. My senses are telling me that I would have to find the parent function of this, then solve that for x and y, and then perform corresponding translations in order to get the parent function in its new form to move to this location. Sounds like a pain in the ass because it is. Right? What's not is putting this into your calculator and getting an answer. All right, so I'm putting it in without the 2 pi. I'm doing that because I forgot to type 2 pi, but I'm also doing that, it actually worked out, because if I put in the 2 pi, I'm going to get an answer that's multiplied by pi. Just via. You're still responsible. Yeah, I always thought about that. I'm like, if I needed to remember, if I was getting a grade for it, I'd remember. I did remember. That's how I got all those 8s. But I don't really need to remember. Besides, I'm losing my marbles anyway, so it's fine. So yeah, leaving off the 2 pi for now allows you to possibly, not guaranteed, but possibly get a cleaner answer. And I can just tack on the 2 pi to that. Right, so that's my thinking after I realized that I made a mistake. So math, enter. So it's a good mistake because that's 29 over 30. So we're looking at 2 pi times 29 over 30. So it's going to be 29 pi over 15. So if you did need an exact answer, that's what it would be, right? But if you didn't need an exact answer, $6.0737 roughly. I mean, I'm kind of hitting hard this concept of getting an exact answer, even using a calculator technique. I wonder if that's something you can expect to see on a test. It's something you can expect to see on a test.